A hidden place for lots of points in the GED math is graphs, functions, and slopes. And they are written in such an obscure, crazy way where it looks way more complicated than it is. There are really 5, but really 4 different ways that they can present something to talk about what slope is. And in this question, there's 2 of them. And this question is absurd. It makes no sense at all. So it's 2 wooden race cars are released at the top of a ramp. So Pinewood Derby, Cub Scout, whatever. Race car 1's distance is shown in the table. So at 0 seconds, it has gone 0 meters. Then in 5 seconds, it goes 5 meters. In 10 seconds, it has gone 10 meters. And at 15 seconds, it's still at 10 meters, so it stopped. So this is total number of meters. So that's that. Race car 2 is in the graph. So at 0 seconds, time is usually almost always this one. So time over distance. Anyway, it's at 0 distance. Then 5 seconds later, it has gone. Now GED's so good at that. It's right in between 4 and 6. So they're doing that 1 extra step of fatigue.
5.
Trying to wear us out. They could have put a 5 there. They could have, but they on purpose did not. So we need to mentally go, okay, but it's between 4 and 6. It looks exactly in the middle. So I'm going to make my guess that that's 5. So it went 5. Then this race car is ridiculous because for the next 5 seconds, it doesn't move. It's a wooden race car. There's no driver. Nobody's hitting the brakes because after 10 seconds, it starts moving again. So that's why this thing doesn't make any sense at all, that it moves, stops, like gets stuck or something like that, and then it moves again. So that's how this thing goes. This thing stopped at the end and just stopped because that's how things go on Earth. And this is, a robot or whatever, who knows? The question they're asking, which race car has the greatest average speed from seconds 10 to 15? So what we have to do is know that slope is just a relationship between 2 numbers. How many donuts can I eat in an hour? How many pizza slices can I eat in an hour? How many anythings can I eat? It's just stuff, time. That's all slope is a relationship between those 2 things. When we see it in a chart, I'm gonna write in red here. We run the zigzag. So I'm gonna click on this right here. What they care about is between 10 and 15 seconds. That's what that said. So between 10 and 15 seconds, that changed 5.
Mm-hmm.
And that is our bottom number. First number goes bottom. We build our fractions from the ground up. Second one is those corresponding numbers. From 10 seconds to 15 seconds, it went from 10 to 10. So it didn't move at all.
This is 0.
The change.
Will you put that 0 on top of that 5, Jeff?
Yes, sir. And that is 0/5 is 0. It didn't move at all. So that's how we read slope on a chart. We run the zigzag, and the left side is our bottom number because that's time. Our left side is the bottom number, and our right side, whatever the change is the top number. So in fancy math, they call that the delta. Delta just means change, which is the variant we're dealing with. Anyway, 10 to 15 seconds, we treat this like a city map or a country map with farms where everything's in a grid. We're ignoring everything here, just like we ignored all that stuff. That stuff doesn't matter. I don't want to make it sloppy, but that's all we care about, is how to get from 10 seconds, wherever it is in 10 seconds, to 15 seconds. And the way we count that is we always go these blocks first. And 1, 2, 3, 4, 5. That's how many seconds went by. That's our bottom number. We always do that. Just like it matches for time. Time becomes our bottom number here. Time becomes our bottom number here. But anyway, we don't have to worry about that. You just do that first. And then we go 5 blocks this way. And then to get to this point, we go up.
3.
Up makes it a positive number. Well, we're at 5 here.
Right.
and we made it up to 10.
Oh, okay. Let's see. Let's say.
It goes up 5. So then 5 over 5 is 1. And really that just means for every second it went up 1 meter, or it went 1 meter. So we could just compare these two. 5/5 over 0/5. Which one was faster? Race car 2. These are such dumb questions. But if we become very calm and just go, okay, they're giving us all this information. When it comes to the table, do the zigzag. When it comes to a graph, do city blocks. Like if they had asked between 0 and 5, same thing. 1, 2, 3, 4, 5, that would be our bottom number. And then 1, 2, 3, 4, look what they, remember, this is what they did to add fatigue. They didn't put that number 5 there, but it's there. So we went up 5. Now, if the line had gone down instead of going up like this, we'd still do the same. 1, 2, 3, 4, 5. That would be our bottom number. And then it goes down 1, 2, 3, 4, 5, or whatever it is. Then that would make the top number negative.
Negative.
That's a fight for another day. So one last thing, I'm going to add a little skill. If we ever, on any question, if we ever want to know which fraction is bigger, 5, let's do 5/6. Okay, if we ever just lost between two things, just cross multiply. 6 times 2 is 12. 3 times 5 is 15. Whichever one has the bigger number over it is the bigger fraction. That skill will come up a lot during the GE test, randomly here and there. That's the way we do it. It's just multiply up, cross multiply up. Whichever one has the bigger number is the bigger fraction.